So guys, this is the basic foundation of networking career. This is a basic foundation. As well as you are gonna learn mixtures of networking components like router, switch, firewalls, servers, some of the security concepts, some of the data center concepts, a bit on the automation side. Okay, so basically we nowadays call CCNA as enterprise topic. Earlier, the CCNA used to be called as routing switching, but it's no more routing switching now because we will be learning mixtures of things from networking concept. So it's more like enterprise topic. Once you are done with the CCNA, once you finish with your CCNA paper, you can climb the ladder, you can go to CCNP, or you can plan for writing CCI. This is from the Cisco certification perspective. But as you know, nowadays, most of the people after CCNA might look for some additional or some different curriculums, not just CCNP. So what they have as an option is, might be they prefer going towards firewalls. Some people prefer going in depth of Python automation. Some people prefer going with learning SD-WAN. Some people prefer going with ACI, Cisco ACI. These are also networking field. So once you're done with CCNA, you have more number of doors open. You can decide where do you want to get into. You want to get into data center, then you go and start preparing for ACI. You want to get into the WAN technology, then SD-WAN is something which you need. If you want to get more into the security domain, then you have firewalls, knowledge of firewall, or need to learn firewalls. You want to automate your enterprise, then Python is something. And if you want more into routing switching, you can get into CCNP routing switching or CCI routing switching, which is also nowadays called as enterprise. Okay, so you have a lot of options. CCNA is your first block. Once you're done with CCNA, then you have a lot of options. You will decide what you need. That depends on multiple factors. It depends from companies to company, right? So let's say first they hired you as a CCNA network engineer, but for this company, most of their prime customers are on the WAN side or ISP, internet provider. So the company want you to be more expertise in routing switching or service provider SP rather than security or data center. Let's say you are in a company where most of its clients are into data center networks. So once you're done with CCNA, now they need you to be more expertise in data center. So you can think about CCNP in the data center, or you can think about the Cisco ACI or Cisco Nexus or VXLAN, right? So company to company decides or depends on company to company. You need to know what your organization provides the solution to the client. Is it more in routing switching or automation? Could be ethical hacking, cyber security, SOC, data center, monitoring support, what they need. Depending upon that, you decide. Okay. And in the networking domain, you have multiple domains now. One definitely is enterprise. You have the security domain, security engineers. You got data center. All this IP phones and all are part of collaborations. All your internet provider related issues are comes under service provider. Okay, these are some very prime domains. Now you cannot be expert of all this, so you have to select what you need. You need data center, you start with CCNA, then get into data center CCNP or data center CCI in data center. If you want more yourself into the security, then you can get with your CCNA, then CCNP security and CCI security. But add on, you can always learn the different uh, firewalls or different vendors of firewalls are available. Okay, so let's not confuse here. That's your next level. First, let's discuss from the fresher point of view only the CCNA and topics related to CCNA. So in this CCNA topic, we will first see today uh, some topology that we can create, because this is where you will practice all your CCNA fundamentals. And also I'll show you the syllabus PDF for your exam 20301. This is the exam code for CCNA. So here is the exam Cisco official website. Okay, and this is the topics that we will learn in CCNA. All your router switches, fundamental, bit on IP services, security, automation, bit on wireless. Okay, it's an interesting topic. So first, for the day number one for today, I'll just give you some basics on first few of the points. Because when I show you the lab topology, you may not understand what are we gonna do on this lab topology. So first, let me tell you what is router and what is switch for today. Later on, we can check on the different things. So we'll go step by step, so you understand the concept in a better way. So let's say network devices. So let me give you one scenario. Let's say you are sitting in front of your laptop, okay, and you are accessing facebook.com. So where is this facebook.com hosted? Might be it is hosted somewhere in US. The Facebook data center will have a lot of networking components. Might be they have their server, and in this server they have hosted this page called facebook.com. Okay, and where are you? Let's say you are in India. Now what happens normally, you will have some internet provider, let's say Airtel or Geo or ACT, whatever. You have paid for the internet connection. Without internet connection, you cannot access Facebook. Agree? So let's say you have some internet connection, you are accessing www.facebook.com. It will first, we say that it's going to connect to the US straight away. But what happens intermediately is it will first connect to its nearby Airtel or Geo service station. So here what happens is first whatever I send www.facebook.com, it will go and hit my nearby service provider, internet service provider, and that service provider will take the responsibility of sending that particular request over here. Okay, in this way. Now, on the other side, the Facebook data center, they also have some sort of service provider. Might be their country, they have like Verizon or Vodafone or AT&T, right? So the request will go this way, and once the request is received on the server, that will reply back in the same way. So this happens all in milliseconds. And then we access this page called facebook.com. Same thing happen when you go and access google.com or instagram.com, youtube.com. Request will go to the server and the response will come back. Okay, so we call this direction as request, and the vice versa direction we call it as response. So this is for every scenario, request and response. But intermediately, if there is any problem, let's say request went, but you might have seen the web page saying that page not found, or page unable to open, right? That happens if there was some problem intermediately. Like, let's say if this is broken, the path is broken. So if the path is broken, definitely you will not able to access anything on the website. Let's say the request which you did at the same time on the Facebook side, the server had some power outage and they don't have a backup. So what will happen? Your request will just go, but you will not receive the response because due to the power outage, that particular server is down, right? So you might have seen all this scenario a lot of time in your real time experience, but you may not be knowing what actually happens in the backend because these are all networking concepts. So what, as a network engineer, you need to do in your company or in your organization? But why? First thing is, why in the office they are using Facebook or YouTube? Because they are not for the official reason, they are just entertainment, right? It's not that in your office you expect someone is watching Facebook or accessing YouTube. It's not productivity. So why we need internet in office? We need internet in the office because let's assume we are not talking about Facebook, but we are talking about some services or some payroll. Or let's say, for simple example, I'm not talking about Facebook because Facebook is for entertainment purpose. In the office, I cannot uh, be expecting I have a Facebook reachability or I need to access that. Let's say it's an official web page. Let's say my company website. I work for, let's say, Cisco. So my company website is this. Agree? Might be I have to log into this website and put my attendance that I have logged in or I have come to my office today, because this is what check and the day on the salary, how many days I attended, how many days I took PTO, how many days I took a sick leave or whatever it is. Let's say my compensation, my hikes, or whatever letter that my company gives me, they have a separate payroll portal or something. Let's take this as an example. Now, this is office work, right? It's my office website. It's not entertainment, it's an official thing. And during this, if there is a glitch, if my attendance is not going on a daily basis, so what happens? I'll not receive salary on a proper time or not on a proper days. I might have worked for 30 days, but due to some network glitch, I my attendance was only 15 days. So I'm losing 10 days of salary. Correct. Let's also take one more scenario, that this is customer. What type of customer? Let's say he has purchased your software. You guys are into softwares. You have some software or some application which you have sold to this customer XYZ. He's paying you a lot of money. to take that service from you. But all of a sudden you see that something is not good. Your server is broken, your server has power outage, or the connection is broken at any point. So he is not happy. He will not pay you, or he will not renew you next time, right? So this is what the network engineer does. He tries to give a better quality of network experience. Between whom to whom? Between the customer and the sellers or the companies who are selling the softwares, selling software. Okay. So customer is one who is purchasing the product from them, some services like subscription, some software which needs online reachability. So he has paid to the company, and company is gonna deliver that for 1 year, 3 months, 6 months, whatever is the contract. And the network engineer is someone who will make sure that there is no downtime, server going down, power in the sense, because of power the server can go down or the network device can go down, right? So he will make sure that there is a smoother transaction between these two persons related to internet. Okay, so this guy we usually call as a source. So source is just a technical word that means someone who is initiating the connection, and company is someone who is destination. Correct. Let's say if you think you're starting from the source to destination and coming back from destination to source. So source is someone who will initiate the connection. Destination is someone who will reply back to that particular request. So it's a to and fro connection. You're initiating the connection and the response has to come from that side. And intermediately and at the customer side and the company side, the network engineer will see that there is a smoother experience. There is no slowness. There is no device going down, right? So that is what network engineer does in the production. And in this path that we have, there are a lot of components from networking side. Like on, let's say on this side, we will have lot of routers kept on both the end. Why these routers are used? Let's say when you are trying to access Facebook, how does that request know that I have to go to facebook.com and not to Google or not to YouTube or whatever? That is because router will maintain some algorithm. It's called as routing table. It knows how to reach Facebook. Okay, it will also know how to reach YouTube. It knows how to reach a website like Cisco. So the routers are important here. When you send www.facebook.com, it basically will resolve to something called IP addressing. And that IP addressing are stored in the routing table. Now what this routing table does, it will check the shortest path to reach there. So if it see that this is a shortest path, then it will start sending the request in that. But let's say if there were multiple paths on the way, you can see to reach this, you have a path via US. You can also reach it via Australia. You can also reach it via, let's say, Japan. So what this router also knows is to reach that destination, I have three paths, but let's say this is going to take so and so cost metric. Let's say it is going to take so and so cost metric. This is going to take so and so cost metric, and this is going to take so and so cost metric. So as I put down here, the shortest is preferred. So it will take the Japan route. Why it will take shortest? Because we need the request and response happens in a very shorter millisecond. Because when you type facebook.com, do you think after 5 minutes that page should load for you? No, right? That is not the good user friendly behavior. You want, when you do facebook.com, somehow you not bothered about whether it is going via Japan, via Australia, or via US. You're not bothered about it. You just want the Facebook page to load. So who takes care of it? These network routers are taking care of it. It will decide based on its principle or its algorithm. To reach this, I'm going to take this path. Okay. Now, this is your CCNA level. When you learn the next level, CCNP, CCI, you also have the capability to manipulate the path. Let's say Japan shows 10, but let's say you wanted to prefer the Australia route over Japan, which is called as path manipulation. I can manipulate the path also, but let's not discuss that in CCNA because that is your CCNP and CCI level where you will talk about path manipulations. Okay, why? Let's say I'll give you one example. Let's say here you have a better devices, but it might be cost of 20. So that is why it's considered as a secondary path. But as we know, there is a good power backup on that path. I know that there is a good reliable service provider on that path. So why not take Australia? Because Japan is good, but they do not have a good uh, reliability. Might be every month there are 3 outage that's happening because they might have a very bad power supply. They do not have a backup. So Japan being a good path, but not reliable. Every month I see 3 outage. So my customer is complaining 3 times in a month that your websites are broken. I'm not able to. So this is where I can manipulate. I can go with Australia as a path to reach Facebook or whatever, Cisco.com or whatever. So you guys are clear till here, this point?
I have a quick question. Who decides whether a path is reliable? Is it a manual intervention or it's automatic?
It can be both way. If you have in a network all HA failover concept, then you when it sense there is a quality degrade, it can auto switch it. It can auto
Okay.
switch it, and also it can auto revert back to the, let's say, Japan as a thing. But when it auto revert, again there is a chances that the customer have a bad impression on the quality. So now manually you can also switches to Australia and fix Australia as a best path for you.
Okay. Thank you.
Prakash and PP, may I know your
Yes, sir.
name?
Me itself, Prakash.
Okay. So are you
Understood.
guys good so far?
Yes, sir. Good.
Okay. Prakash Singh, are you good?
Yes, sir. Yes, sir.
No, I am asking Prakash Singh. He's also Prakash.
Yes, sir.
Okay. Then let me draw one more diagram. Let's say this is source. Who is source, guys? Tell me who is source. I have a bad habit of asking question on every start of the class. So I'll definitely ask few things so I know you are uh, with me and not lost. So who is source?
Oh, laptop. Huh?
Yes, but when interviewer will ask, you don't say it's a laptop. Source is a one who is initiating the connection. What would you answer?
Initiating the connection.
Yes. Who is a destination?
Server.
Yes, but again, sir, that is from our diagram. But if interviewer is asking you, you will say who will reply back for the request. Okay, source is initiator, destination who responds back. And intermediately, let's say this is India, this is US. They are all miles away. They are not like just you get down off your house, you get US or servers kept. They are miles away. Okay, so this is connected initially. Let's say you have a connection with Airtel. Now there is no 100% guarantee that Airtel will directly take till this ISP, let's say AT&T. There is no guarantee that Airtel and AT&T are directly connected. In between, there can be lot of local internet providers. Okay, let's say from this point to this point, Airtel is dependent to Geo to reach this. Let's say then Geo has a contract with Vodafone to reach another 500 miles. Let's say Vodafone then do not have a connectivity till AT&T. Might be Vodafone has another dependency. Might be they take back Geo. That is also possible. Geo, Vodafone, and then Geo for next 1,000 miles. Then Geo might have paid money to uh, let's say Aircel, or let's say okay, there are a lot of things. Okay, Verizon. Let's say Verizon, and then Verizon is connected to AT&T. Okay. Now, why I have done this is because don't be in a impression, don't be under impression that Airtel and AT&T are directly connected. That is not possible because these are thousands miles away. Let's say I put it this way: 5,000 miles away. No one can put a cable on the on the Airtel side and take that cable to the AT&T side. It's not possible. There is also chances that your data, that your the request and response, whatever you're carrying, they also can get downgraded because of the distance. You might know that, right? So if you have a lengthy hollow pipe, you put some, let's say, drops of water. Let's say you put 100 drops, but there's no chances that all 100 you will receive on the other side because the pipe might have consumed some portion of it. Maybe you receive 90% or 80%. But in networking, if you happen to see that if 10 packets you send, but you received 5, so the quality will change. Customer will say, I am not able to watch the video. I'm not able to hear the audio. The quality looks very blur. That is when happen that those things happens when the packets are lost. Okay, you are sending some packets, 100 packets, but you're receiving back only 5, or you're receiving only 50. Now in this scenario, all the things like slowness, page not loading, or the quality degraded, or audio not downloadable. So all this challenges happens when this connection between Airtel and AT&T was not good. Okay, so these ISP also, ISP or service provider also rely on a different people to send their packet. So here, Airtel, you might be paying the bill to Airtel, but Airtel internally is connected to all other guys. And on the other side, might be FB, Facebook was paying money to AT&T, but AT&T is paying the other people as well. And also remember, you will see some of the portion on a land, some of the portions on the submarine. Submarine is nothing but the ocean, and you will see again land. So on the ocean, not all of them has the cables. Might be Jio has, Tata has, Airtel has, right? So there is always a dependency from one ISP to another ISP. If you have to see the submarine cables, how the network is connected from one source to destination, you can refer back this website. See, these are the cables. These are called optic fiber cables, and these are under the ocean. So if you check here, India, see, we have a lot of cables which are connecting countries to countries. These are all optic fibers. So if you are reaching to Facebook, which is in US, you can just minimize this. Okay. So let's say I take one cable which is connecting straight away. See, if I take this cable, it's not something what it's connecting India to US. So let's say I take one from here. So if you take this cable, it is connecting India to Italy. Might be from Italy, I have to, those ISP in the Italy will have a different cables purchased. Let's say I take this cable. See, might be that cables will connect to US. So that is why I said the concept of shortest path, because to reach US you have multiple ways. It's not that from US to from India to US you will have only one cable. You can go countries to reach US. Might be there can be one easy way as well to reach there. So let's say if I check this cable, let's see how it is reaching there. See, this cable at least will take you till South Africa, and from South Africa you can see this cable which connects to this, right? So there are a lot of ways. Thus, who will decide the shortest path? Guys, who will decide the shortest path? I told you example also. Who is deciding in networking? Who is deciding the shortest path?
The router.
Yes. And what router is gonna maintain?
The routing table.
Yes. So router will maintain routing tables. Router will know all the different paths. It will know the path from South Africa to US, might be from Japan to US, from Australia to US. But then they also know what is the cost to reach there. Is it 10? Is it 20? Is it 30? Is it 40? And depending upon that, it will take the lowest and consider inside its algorithm. And the rest would be kept aside. It will not be discarded. It will be kept aside. Why it will kept aside is when the shortest path for some reason is down. So it should still pass the traffic to the destination, right? So what it will do, whoever was the second best will now act as the best one until the previous best comes back. Once the previous comes back, this goes back to that different tables. So this is all router does. Router will interconnect the networks. So if I have to tell you in a layman's world, what is router? Router interconnects different networks. Okay, interconnects different networks. Simple example was this. I have routers on every boundaries. Cisco routers. So the router from Airtel will decide how to reach Facebook via the Geo or via the South African region or from Japan, whatever. So the router will take the decision to take or to travel in this direction. Okay. And if you see the pictures of routers, they are not something like some NASA device or something. These are very simple to look devices. See, these are some routers. This is how our routers look like. Now you might be wondering how this small box of device will take all the decision of going via this path. Some tables like routing table, connection tables, or the standby tables, right? So these routers are very powerful and also very expensive. They cost in lakhs, 3 lakhs, 4 lakhs, 5 lakhs. A very basic model you can get from Amazon, which can cost 30, 40,000. And I'm not talking about the modem that is inside your home. It's just your home modem or home router, which people call. They are just from home purpose. Whereas these are enterprise levels. Companies use them. Okay, these are company levels. And these routers are very intelligent. They, apart from interconnecting to different, they are maintaining all the paths, right? They have a intelligence to maintain all the paths to reach various destinations. They have the capacity to take the decision in milliseconds, right? So they must have some uh, chips on their motherboard which can take the decision such a quick way, right? So let's see the architecture of this routers, how the router internally would look like. They're all electronics and the registers, the memory units. So this is how the inside part of a router or a switch would look like. These are all electronic stuff we don't have in our networking, but just I'm showing you that packets, the request and reply, all that decided via these components. So there is a control plane, there is a data plane, there is a management plane, right? There are a lot of things that you will learn just in this piece of boxes. It's not that you connect it between one service provider to another service provider and they will automatically do the things. There are a lot of internal architectures in this present. Okay, so we don't worry about how we create etc because these are all electronic stuff, register, diode, etc. So someone who is very expert in the electronics will prepare these motherboards and assemble them. But once you assemble them, then they would look something like this. Okay, this component. Now someone gives you this box, you as a network engineer should know how to configure its operating system. Okay, that means once the router as a hardware is given to you after assembly, let's say this is the router. So this router has two things. One, hardware. Hardware is nothing but all that internal chips, the different interface or port which we call, that is hardware. It also has a fan inside it and software. So these are the two things that is in a router, hardware and a software. So you as a network engineer, you have to know how to configure different networking concepts or networking protocol on a software level. Like you should know how you configure a routing protocol. You should know how you can configure the interfaces. You should know how you read the ARP table. How do you read the MAC address table? How do you do how do you initiate a ping? These are all considered as a protocol. We'll come all to this in very short span of time. For now, let's stop the theory. Okay. Any questions so far? We have not gone to switch. Let's be on router for now. Let me just show you the router interface. on one of the lab. So guys, let's say you are being asked to practice on router, right? Because as I told you, we will be dealing with routers and all those things. So how would we practice it? And I told you it's very expensive. We cannot go and buy one hardware and power it and start using. For that, we need some lab. So we here in Network Journey will give you the lab access. There will be one icon called GNS. So using this GNS software, we can just see the different software levels, protocols, etc. by deploying it on our home lab itself without paying any money to the hardwares or not spending money on the powers or etc. These are the virtualized labs. So I'll give you the demo of this. This is a GNS software. You might have heard about Packet Tracer. If not, Packet Tracer is also something which is used in CCNA level. But I'll prefer going with GNS because Packet Tracer, some commands may not work. Whereas GNS, you can even practice CCNP, CCI level. Alternative to GNS are EVNG, which is also a good solution, which most of people use. Okay, so GNS is one of the very popular networking lab software, where you can plug the router and configure them. See, on this side, on the left hand side, I have few devices. So let's say this is a router. So I just have to drag it like this. Okay. So once I drag it, I right click on it and I click on the start button. So this is in a virtual environment. If someone gives you this hardware, you basically will get some power cord. You will connect it on the router and plug it on the normal socket. So once you power it on, this will start processing. As I told you, it has memory unit and all this thing. The software will start spinning up. And once you start spinning up, you can connect this connection to your laptop or your computer, and you get the same terminal, the terminal that I am gonna get right now while I double click this. Okay. Once you have this, the console that I'm just showing you, the black and white screen, this is same for virtual. Also, it's same for the hardware. Okay. The only difference is the physical appearance of it. You will see this when you join some company, networking company. But since we are doing a lab now, we can just replicate a hardware in terms of some software levels. Okay. But later on, all the consoles are very similar. You can do pretty much everything that you are supposed to do on a production devices. Okay, so this is the software. How do I check what type of softwares are inside this? I need to know some commands. So I can say show version. So when I do show version, I get to know lot of details. So this is my software 15.6. 15.6 is sitting inside this type of devices. Now that 15.6 is not universal. It can be 14, it can be 13, it can be 16, it can be 17. Old devices are still running on 13. A new device or recently purchased devices having 15, right? You know Android mobile. When you buy a mobile, if you purchase some time back, you might get Android 10. Let's give an example, 10. If you buy a mobile today, might be the new Android 11 has come and you are getting a new version. So what those older people or the people who purchased few days back, what they will do? They will upgrade it, software upgrade, very simple, right? You go to settings, you will get the new upgrade popped up that there is a new update. You will upgrade it, reboot, you get a new image on your old phone. Same way. On this device, if I purchased 2 years back, might be it is running 11 series, and now I have 14 series. I'll download the new image. I'll set the boot variable. I'll upgrade. I'll reboot. After my reboot, I will see that this device is having the new image. Okay, so it's all very similar behavior. Right now, this is having 15.6. So these are some types of commands. We'll talk about this. Those are interface. This is how you will see the routing table. This is a routing table. You can see if there is any protocol enabled as of now. You can see the configuration of this device, the complete configuration of this device. You can see if there is any logs. You can check here. Okay, so these are all your devices. You think about your mobile will have a lot of features, media player, the galleries, etc. If you want to upgrade, you have settings. You want to connect to another mobile for some data transfer, you will need some application, right? So you need some things to be done on a software level also. So these are also routers. A router also does the same thing. Once they come as a hardware to, let's say, some company purchase, then their network engineers will decide what they need it, which protocol they need to configure, what IP address they need to configure, what security concept they need to configure. All right, guys. So I want to build one lab topology with you guys as well, showing you guys. That's why I'm not build anything for CCNA. I'm planning to get this lab topology done. Okay. So in this lab topology, I'll just tell you where are routers and switches and other components. So these are all our users in the sense with laptops or computers, or could be a Wi-Fi modem, servers, printers, HR team, marketing team, uh, reception, whatever users they are basically connected to these Cisco switches. So we have to configure these Cisco switches. The Cisco switches will connect to the, let's say, firewalls or something. So I'm not sure whether you guys are aware. Those who all taking our CCNA, we are going to give you guys a Cisco ASA firewall for free of cost. So this will be a recording that you get for Cisco ASA firewall, not a live batch. It will be recording of 30 hours that you get along with the live batch of CCNA. Okay, so because these are very commonly asked these days, when you appear for interview, they ask for routing switching with one of the firewall knowledge. That's fine. And also, I've kept this as an option for now. If we want to skip, then we definitely can skip the firewalls. But if you are interested to have 1 or 2 sessions covered on firewall, then I'll also show you where and how we configure or plug these firewalls.
Please do, please.
Okay, yeah, sure. Okay. And these are the routers. So always routers are kept in the north direction. North direction in the sense which connects to another network. Okay. Let's say this whole setup, whole enterprise setup was for AT&T or any other service provider. Let's say Airtel. This is a Airtel setup. Now, the similar type of setup, the other ISP will also have it. He will also have his users, switches, router, firewalls, etc. So on the top side that you see, the router, they connect with another router on a different enterprise or a different service provider. Might be this is a different router. And in the backend, they will have different types of switches, printers, users. They're all in the backend. We don't take care. We don't from this person perspective, from this point of view, I don't need to know what users and etc. My request will go from this person to this person. This person will send the request to another router which is connected in different location or something. Okay, so that is why I said routers can interconnect different network, because this is some network. Okay, this is some network in the IP range of this, whereas this is another network in a different IP segment of this, whereas this is on a different network which is on so and so. That is nothing but, let's say this is India. India, you have connection with Airtel. The Airtel is connected to Geo, and let's say that is in Japan or something. Then that is connected to another network, which is let's say AT&T in Australia, right? So this is how the request from one source to destination goes from a different router. There will be multiple routers maintained and managed by different entities, different service providers. So we will touch one complete enterprise, one complete office network. You can also think this from office network. I'll take one class where I'll show you the network design, how users are connected to switch and how switch is connected to router, how user is connected to Facebook, how user is connected to VPNs, how the actual networking things happen. Okay, you as a network engineer need to give this smoother transaction. User should not say, I'm not able to connect to VPN. User should not say, while I connect to Cisco.com, I have very slow website loading up on my page. User should not say that the page is not found IC. Basically, the network engineer will try to resolve this issue, or at least he will try to narrow down the issue. If the server is not working, then it's not network engineer's responsibility, but he has to find out, or he has to identify the root cause. He will tell the next person or the rightful person that the issue is with the server looks to be down, call your electrician or whoever, bring up the server. From the networking side, routers and all other things are all running fine, there is no problem. So he has to identify. Okay, this is what in a large scale a network engineer does. All right, guys, we will wind up here. Tomorrow we will try to configure this on our empty lab here. One second, on this emulator. I will show you how you deploy two routers, how you connect a cable between them. So what you see is called as switch port or interfaces or port. Okay, how do you make this person, this guy, to talk to this guy, the second guy? Okay, so we will go step by step, and also we will configure this whole lab topology over here, so that you also know how these are configured and how actually the network enterprise looks like, so that you can also create a very smaller topology. I'll give you one project on very end, at the very end, where you have to create your own small scale office network, might be for 10 users. I want the users to communicate. You have to decide which network, IP network you want to go. You want to go with /24/26. We are yet to come with all that concept. So you will design me one small network, and you will talk about that network, what you did and why you did that. Okay. So that is something we'll check it out.
Are you also going to cover how to, like subnetting and?
Yes. You need to know the subnetting to decide the IP schemes and all this. We'll discuss.
So you'll be covering. Okay.
Okay. So any doubt, GS, Prakash and PP?
No, sir.
Okay. So all clear with today's class?
Yes, sir.
Okay. I'm taking 1 hour because too many hours or too much of content will definitely be not useful. Okay. If we want, we will increase it later, the space and the time. But for now, we can keep it this. All right, guys. So let's connect tomorrow. Have a nice day. Okay.
Okay, thank you.
Sir, this video will be recorded and sent later.
Yeah, yeah. It will be recorded, and I will give you the web portal access so you can watch it there.
Web address, sir.
Sorry,
Web portal address.
I will inform in our common group.
Yes, sir. Okay.